In this problem, we'll be having a look at the following limit, which involves some square roots. So we have to find the limit as x goes to 2 of the square root of 6 minus x minus 2 divided by the square root of 3 minus x and then minus 1. First thing we could try is to set x equals 2, but the problem is that the numerator and denominator, they both end up equaling 0. So if you put square root of 3 minus 2 and then minus 1, you get 0, and if you put square root of 6 minus 2 and then minus 2, you also get 0, so you get indeterminate 0 over 0 form. So this means you cannot directly substitute x equals 2 to find the limit. What we could try instead is to see what happens if we multiply by the conjugates of these square root expressions. So if we multiply by the conjugates so for both the numerator and denominator, we multiply by square root of 6 minus x and a plus 2 instead of a minus 2, and we do the same on denominator. And also we can multiply the numerator and denominator by square root of 3 minus x plus 1 and square root of 3 minus x plus 1 on denominator as well. And now if we do that, we can now apply difference of perfect squares. So over here we have difference of perfect squares to get 6 minus x minus 2 squared. And if we apply difference of perfect squares here as well, we also get 3 minus x minus 1 squared. So this simplifies to 2 minus x over here. And we also have 2 minus x from here. So 3 minus x minus 1 squared is also 2 minus x. And now we have these two expressions. So before we had minus 1 and a minus 2, but now we have pluses now. And so when x is not equal to 2, you can cancel out the 2 minus x's over here, and we end up getting square root of 3 minus x plus 1 divided by square root of 6 minus x plus 2. And now if we try to compute the original limit using this expression we've got here, you can instead now find the limit of the square root of 3 minus x plus 1 divided by the square root of 6 minus x plus 2. And so this is allowed because this identity always holds when x is not equal, when x is close to but not equal to minus 2. Sorry, not equal to 2. So we can apply this identity, and now putting x equals 2 actually works, because if we substitute it in, we get square root of 3 minus 2 and then plus 1 divided by the square root of 6 minus 2 and then plus 2. And now it's no longer equal to 0, so we have 1 plus 1 divided by 4 plus... Okay, in fact that should... it's a minor error. So I should say the square root of 4. So square root of 4 plus 2. So in fact the final answer is not what I've written. It is actually going to be 2 divided by square root of 4 is 2, and plus 2 gives you 4, so I have 2 over 4, which is equal to half. So final answer for our limit is going to be half. That's all I have for this video. Hope you enjoyed. Thanks for watching, and I'll see you next time.